When you add together numbers that are complex, you can break out the I, if at all possible, if multiple items are being multiplied by the I. You see how they took the A and the C and they combined it, and they took the B and the D and they multiplied it by I. Let's do an example 1, and I'm going to make this a whole lot clearer. 3 plus 6I added to 4 minus 2I. Okay? This is like me saying to you 3 plus 2x added to 4 minus 3x. I don't know, I'm just making stuff up. Okay? You know that you would have to combine the 3 and the 4 because they are numbers. And you know that you would have to combine the 2 and the negative 3. Okay? And that's the end result. The parentheses, because of this scenario, really don't mean a whole lot to us. Okay? I would simply combine my 3 and my 4, and I would combine my 6 and my negative 2, and you're going to end up with the exact same answer that they show you. Now, the way they show it, though, is to group the numbers and group the coefficients of the I, if you want to call them coefficients. Okay? And in any case, you're going to end up with 7 plus 4I. Okay? But again, I just look at it and say it's all combining here. 3 and 4 is 7. The i's get combined, and that's your 4I. Okay, so when you see something like this, think of it as if it was simple variables and numbers and how you would handle those. You certainly wouldn't make the answer of this 11I or 11 because you know that constants and variables, if we want to call it simply a variable, this irrational or imaginary number, these two things can't be combined. 7 is a number, the I is imaginary. B works very similarly, and even though it's a negative, we're going to treat it all the same. And I even like to use the rules that I always use with negatives and positives. Minus 2I. Okay? This negative number affects both the 4 and the 2. Okay? So if you do it the way they do it, you would combine the 3 with the 4, which is a negative, and you would subtract the 6I and the 2I. Now, remember, I took this negative, it made the 4 negative. I took this negative, it made the 2I negative. You still need to keep this, though, because obviously the number and the imaginary number will not separate. So you're going to end up with negative 1 minus the sum of 6 and 2. Oh, I should have just, I'm sorry. 6 and 2 is 4. What did I write? 6, oh, positive 6, negative 2. Positive is 8. 8I. Lost my place there for a second. Okay, the 6 and the 2 is 8. Okay, this should be a minus sign. Okay, combine your numbers. 3 and 4 is a negative 1. Minus, change the sign, combine your imaginary. Okay, it's a little bit tricky. Just make sure that you recognize that this is still going to exist and this affected the signs. Okay? Yes, sir. Yeah. Wait a minute. Negative, hold on a second. 6, yeah, see, I don't know, see, that's what I noticed. Okay, yep. The way I like doing this is easier than their way, and I'm just going to show it to you, because that's how I make mistakes when I do it that way. 4 minus 2i. I prefer to go plus, negative, positive, and then my signs are always right. If I don't do that, for some reason I make stupid mistakes, like that one. Negative 1 plus 8i, because the sign of the I changed. So I always like to take a subtraction problem and make it adding the opposite. So instead of minusing a 4, we're adding a negative 4. Instead of subtracting a negative 2i, we're adding a 2i. Okay? Flipping the signs. That's just the way I do it. Obviously, I make less mistakes when I do it that way. Okay. Foiling, example 2. It's going to look just like normal foiling, but you have to be very diligent. When you multiply your i's, you end up with I squared. And if you remember from a couple lessons back, I squared is a negative 1, right? I believe it is. Okay, let's do the first one. 3 plus 4i multiplied by 5 plus 2i. So 3 times 5 is 15, that's my F. O is 3 times 2, so that's a positive 6i, that's my O. I is a positive 20. And last is a positive 8i squared. Okay, I'll fix that in a minute. So this is my F. If you're thinking FOIL, this is my O, this is my I, and this is my L. Okay? 15 plus 26i. Obviously, we're good on that. 15 plus 26i. But remember, I squared is a negative 1. So that makes that a negative 8. 8 times negative 1 is negative 8. Okay? Combine like terms, and you'll have 26i plus 7. Okay? And you could write it the way they do it too. So I just like writing my variable looking things first. Okay? Either way is fine. That's A. B. Again, foiling. But you can think of it like that old pattern up there, squaring binomials. It's the second thing I have written up there. 3 plus 4i squared. If you think of the 3 as A, and you think of the 4i as B, and you square it, the result is A squared plus twice the product of A and B plus B squared. Ran out of room. Okay? You can also break this up and do 3 plus 4i multiplied by 3 plus 4i. I don't really care. Okay? Whichever way is the one you click with. A squared, 3 times 3 is 9. The product of A and B, which is 12i doubled, 24i. B squared, positive 16i squared. Okay? This times this, that I squared became a negative 1, which makes that 16 negative. Okay? In the end, you combine your 9 and your 16, negative 7 plus 24i. Okay? Watch out for that I squared equals negative 1 business. Okay, if I remember right from last year, a lot of people would leave this. And unfortunately, that would be incorrect, okay? You have to replace the I squared with a negative 1 because we learned that I squared is negative 1, and we learned that the square root of negative 1 is I. Okay? Seems sketchy, but it's true. That's the imaginary number that was created. Last one. Looks like a difference of squares to me. 3 plus 4i, 3 minus 4i. Looks like a difference of squares to me. And you could FOIL it. 3 plus 4i, 3 minus 4i. Okay, if you FOIL it, you're going to get 9 minus 12i plus 12i cancels themselves out, minus 16i squared. Okay? Knowing that these two have canceled themselves out, this becomes a 16 times a negative 1 negative, that's a positive. 9 plus 16. Okay? So this right here is negative 16 times negative 1. That's how I came up with a positive 16 in this position here. Okay? Okay. Hopefully you guys remember the term conjugate from radicals. Conjugates are, in essence, something that cancels out the radical or the imaginary number by creating an actual rational looking integer. Okay? Example 3 has us starting with that. This is all very similar to how you've worked with numbers before. Example 3, this is where you encountered radicals. 5 minus I, 2 plus 3i. Okay, and they say simplify this. In order to simplify this, just like with radicals, you can't have an imaginary number down here. Okay? So, simplifying it means multiply both pieces by the conjugate of the denominator. Okay? Conjugate. By doing that, in the bottom, we're going to end up with 4 minus 9 times negative 1. Okay? Because the O, which is a negative 6i, and the I in the word FOIL, which is a positive 6i, cancel each other out. Okay? So by doing this, we have effectively eliminated the I in the denominator. Okay, I'm not trying to ignore the numerator, I just want you to see the effect it has. So it becomes 4 plus 9. Okay, we'll deal with that here shortly. Okay? Which they kind of take a long time to do it. But here, I'm going to go ahead and do this. The top, FOIL it. And I'm going to move down here. 10 minus 15i minus 2i, negative negative plus 3i squared, all of that over this, which I'm going to simplify here shortly, 4 plus 9. Let's combine some stuff. This and this, that becomes negative 17i. I squared is a negative 1, so that becomes a negative 3. 10 minus 3 is 7. Okay? All of that over 13. You guys see that so far? Now, this is the way I've always written these answers. But the back of the book is going to break it up and list it like this. Okay? And they might even have the I sitting off to the side. So just notice, if you tell me this, I'm okay with it. Okay? But traditionally, breaking it up, I guess, has become the new thing, the thing. I've always done it this way. Okay? Find the reciprocal of a number. Find the reciprocal. This is example 4. Actually, hang on a second. So if I say to you, find the reciprocal of 6, you're going to say, put a 1 over it, Mrs. Myers, and there's the reciprocal, right? That's easy. But if I say to you, find the reciprocal of 3 minus I, you're going to quickly put a 1 over it. 1 over 3 minus I. Can we leave it that way? No, unfortunately we can't. Just like in the above, you have to multiply by the conjugate. Okay? The numerator, 1 times 3 plus I, that's pretty easy. 3 plus I. The denominator, so this is like a difference of 2 squares. Looks like it anyway, once it's done. 3 squared is 9. I times I is a negative 1. Okay, F, O and I cancel out. I times I, negative 1. So you end up with 3 plus I over 10. Doesn't look like the reciprocals we're used to, does it? It's really crazy. Okay? So start by taking what you've been given, flip it, and then clean it up by using the conjugate. Okay? That's it in a nutshell.